piecewise defined functions are defined by more than one equation. So here's an example where f of x equals x squared if x is less than or equal to 1, or f of x equals 2 if x is strictly greater than 1. So let's look at this graph to the right. So you can see the piece on the left, it looks like a parabola everywhere where x is less than or equal to 1. And then the function changes its shape at x equals 1 and looks like a constant function of the value y equals 2. So that is what we call a piecewise function, where it takes two different equations to define the function, or two or more really. So I'm going to call the parabola the left piece, and I'm going to call the constant function of 2 the right piece, just to give it a name. And we can see if we plug in the values of x on the domain x less than or equal to 1, the domain values where x is less than or equal to 1, let's say -2, -1, just to see where they lie. Well, if we take -2 and we square it, we get 4 for y. If we take -1 and we square it, we get 1. So you can see that at -2, 4, we're on that parabola, and of course at -1, 1, we're on that parabola. What if we plugged in 1? Well, we do figure out what is 1 squared, and that is 1, and that's why we have a solid circle there where the parabola stops. But now if we go to the right piece, which is y equals 2, because when x is strictly greater than 1, y is always going to be 2. But I like to look at the boundary point and see where I begin drawing that line. So I would plug in 1 to the second piece of the equation, but here where it equals 2, that's actually a hole. And you can see in the graph that we did already have a hole there. Otherwise, this wouldn't be a function. And then let's see, if we plug in 2, we're going to always get 2. We're going to get 2 forever and ever as long as x is strictly greater than 1. So the parabola looks like the equation y equals x squared until x is equal to 1. And then the function changes its shape and looks like the equation y equals 2. So the domain is defined everywhere because there's no number that we can't use for x. The only number in question is the number 1, but it's defined on the parabola. And then reading the range is just looking at the graph itself, and we see we actually can be 0, and then we can be any number until infinity. As we read from large negative numbers, the graph begins literally at the origin, so y equals 0 on the origin, and then because the left piece goes on forever and ever in both x and y direction, to the negative numbers in x and to the positive numbers in y, the range can go to infinity.